put those. Final presentation schedule. So this is the right one. So on Thursday of next week, Christina, Arpit and Kunal and Gua. I think I said that last time, didn't I? Yeah, we'll be presenting. So, and then on the Tuesday after that, Tong and Avi and Vishnu will be presenting on. So that's a week from. That's on. So this is a week from today, the first presentations, and the following Tuesday, Avi and Vishnu and Lakshmi. No, Lakshmi won't, but Tong and Avi and Vishnu will. So. I would, it might be a good idea if you work on them this weekend. You guys are going to present it on Thursday, and that'll give you a chance to ask questions in class if you have questions on Tuesday. So, today we're going to talk about ATL, and so let's go to the ATL lecture. Let's go just interactively and build a component that doesn't do anything useful, okay? Just so you see how the wizards work and stuff. So, you need to run as administrator. So, run as administrator. And I made this start page font big, and I don't know how to make it small again, so I lost the recipe. But let's create a new project. I don't want to. Would you let me get? I'm really frustrated. So, project. So, file. Thank you. New project. So, we go to ATL. There's only one ATL, and this builds a shell, and we'll get to say whether this, and I'll let it put it in this default name and its default place, and so I'll say OK. And now I get to say whether this is an in proc or an out of proc component. We're going to leave it as in proc. Most of the stuff you don't need to change. Allow merging of proxy and stub code. It makes life a little easier. There's one less project to deal with, and it takes care of a lot of stuff for you. So, I typically do that. Just click that one box. Okay. And this builds a DLL that has nothing in it other than DLL main and stuff like that. It has a, but there's no com component in it yet. So if I go here and say add, you can say add class, but don't, because that adds an ordinary C++ class. If you add new item and go to ATL, now you can pick simple object, and you don't want any of these others. All these others have a whole bunch of agendas going on. For project one and for most things you do, all you need is a simple object. And, you know, let's change this to test. And we'll add it. So now, you know, I'm going to get a component test, and its header file is test.h, cpp, test.cpp, and it has an interface itest. And if you go down to other, we get to choose what apartment model is it's in. Apartment is almost always, at least for the things we're doing, fine. Aggregation we haven't talked about, and I don't know whether we're going to get time to talk about aggregation. Aggregation is not C++ aggregation. It's not, we're just making a reference to a component we create on a heap somewhere. It's not what that means. In COM, COM has a when we create a proxy, you build a proxy manager. And if you have more than one interface for that proxy, so if the component you're needing to build a proxy for has more than one interface, the proxy manager gets an in-proc DLL for each interface. But the intent is to present that to the user as a single object, the proxy object, that happens to have two interfaces. And so now things get interesting, because if it's a single object, no matter which interface I'm on, if I query for iInterface, I should get the same pointer. That isn't what will happen. If I don't do something fancy, that isn't what will happen. I'll get IUnknown for the DLL for the first interface, and then when I query interface for the second interface, I'll get the DLL for the second interface, the IUnknown pointer for the second. IUnknown pointer is like an identity. So, so the model is that we're going to make that all of those DLLs appear like one. If I query on any one of them, I got to be able to get to the other one. Lots of fancy footwork going on. It's really quite complicated. And the process of making of one object like this proxy manager, making other objects appear to be part of the same object is aggregation. That's what aggregation is all about. And there's a fancy query interface that, you know, if you're querying for a pointer that isn't mine, I'll take you to where, you know, where it's got to go. It's really complicated. That's aggregation. And aggregation is quite complicated to implement, but COM does it, the ATL does it for you automatically. And by default, they always set it up to use aggregation by default. In the old days, you know, the guys who built the proxy manager were so proud of themselves that they got it to work that they told everybody, that's how you do it. You combine things this way using aggregation. If you want to build composite object, you must use aggregation. And that was a load of baloney, okay? And finally, one of the main architect guys in Microsoft said, oh yeah, that's a lot of baloney. You're crazy if you do it that way. But they built into ATL, it does all that for you, you know. So that's what aggregation is all about. If we have time, I'll walk you through that. We'll talk about it a little bit, but it won't be today. Dual interface. So what dual interface means is I support both my custom interface and I support this automation interface, this universal interface, so that scripts can talk to me. And the idea is simply that C++ clients can talk to me, but actually C# uses an automation interface. It doesn't use the custom interface. It uses automation. And scripting languages like Iron Python and Iron Ruby can use COM objects through that automation interface. So if you select dual, it'll work for your C++ clients, it'll work for C#, it'll work for Iron Python, it'll work for Iron Ruby, all that stuff. So you typically do. There's error information handling, which we're not going to explore. I will talk, if we have time today, a little bit about connection points, and I'm not going to select it here, but I'll show you what it does. And so basically, normally you'll just leave this as it is. You don't need to do anything. The defaults are really what we want, and so we'll just say finish. Is there anything on the file types? No. Okay. So now we have a real COM object that has an IUnknown interface, but no other methods in it, no custom methods in it yet. So if we look at class view, here's our ATL project, and this guy, this CATL project module is the guy that implements, determines whether this is an improc or out-of-proc component. So this base type, because we selected DLL, it chose this wrapper that's going to generate, that does all the COM operations the way we talked about in the diagrams and stuff. If I chose EXE, it would have set things up using the running object table, like we talked about briefly last time. So anyway, now I have an interface and it doesn't have any methods in it, okay? But I want to add some methods to my object, so I just right-click on that interface and I say add, and I say add, and where are your... Oh, the other side. Yeah, my eyes aren't very good. So I'm going to add a method. So here, I'm going to say, because I did this in one of the handouts, I'll say my method name is putString. So I'm going to do the beginning of one of the projects we're going to talk about. Now, parameter type. So I'll pull this down and I'll check beaster. And I want in, tell COM that this is an input parameter, and I'm going to just name the variable str, string. So this is really building IDL as well as a shell for the method to implement that. So it's building IDL, and it's building, there is a test.h and test.cpp. It almost looks like ordinary C++. ATL kind of does that for you. So now, yeah, I can't go around this quirk of this dialog that I have to, if I want two methods, I got to click out of it and then come back and add another method. If I try to add another method here, it'll just overwrite the first method with this. So whoever designed it, you can do better than that, Frank. But anyway, so now notice I have a putString method on that interface. Now let's do another add method. Now I want a getString. Now notice I want that to be an out parameter, but I can't select it. But if I go down here to parameter type and pick beaster star, aha! Okay, now I can select them. So I'll make this an out parameter and a ret val so that it'll appear like a return value for C#. Okay, not for C++. And I'll call this str. I'll add it, finish, And now my interface has both methods. Okay, cool. So now let's go back to the solution view, and we'll see that we have test.cpp and test.h. Here's test.h. So this is a building. So the IDL in our raw C++, we didn't have a header file. We had IDL, and then we ran the MIDL compiler on it, and it built header files that you don't want to look at. Okay, that had stuff for your interface, but it also had stuff to build a virtual function pointer table if this was C, and a bunch of stuff. So lots of stuff. But ATL is giving us stuff that begins to look a little bit like a C++ class, template class, and there's a bunch of, so I'm deriving from a bunch of objects, and part of our job today is to talk about that a little bit. And in test.cpp, here's the methods. And so now I can just go and implement them. Okay. And if I look at the IDL, sure enough, it built the IDL for me. So I didn't, other than using the wizard, I have stuff that doesn't look that far from a normal C++ development environment. Okay, I have a header file, not too terribly complicated. Yeah, it's got stuff on it, and it's my job to help you understand what's there today. Okay, and we have an implementation file. We just put some stuff in it. Away we go. We got a fully functional component. So, so that's that. Let me just put this down. I won't close it because we might want to look at it some other time. And I have a outproc presentation that's got some stuff we really want to talk about, but not today. Hopefully on Tuesday. So the first thing I want to do is pull up a demonstration of simplified ATL structure. I could run this, but I probably won't. So my goal here is to show you why this ATL header file looks the way it does. So here's our test.h, and we're deriving, let's go to full screen mode, we're deriving, lots of stuff. And, if what's going on here is I haven't run let's run it. Let's come down and compile the IDL. Okay. Now, some of this stuff is, no longer read out, and as we, if I just built this now, I think probably, let me build the solution. So we succeeded, and IntelliSense hasn't caught up with me yet, but these are defined. They're defined in the in this ATL project _ I.C. And but anyway, so what's all this stuff? So I put together this is not COM. It's my simulation of the stuff that COM is doing. So I have a component that represents our test.cpp. Okay? And I'm inheriting from iComponent. This is my IUnknown and iComponent. This is my, and this isn't a real IUnknown. This is my little simulation of IUnknown, okay? And so this iComponent represents my custom, the put string, get string interface. And iCreatable is the class factory and setting up some lifetime management. And iStandard process impl is just stuff. What happens is, as we make choices in the wizard, we would add things, more things that we're deriving from that are just standard implementations. One of the nice things about ATL is that we don't have to reinvent all that standard stuff that the Microsoft guys have built, and been using for years. With raw C++, you have to reinvent it. You don't have the, but ATL has the code for a lot of those things, for persistence and yada, 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 okay? So I'm representing that with this iStandard impl. So there's an iStandard impl interface and a standard processing. So let's go in and take a look at what's going on here.
Professor?
Yeah.
Can you take it?
Yeah, help yourself. If anybody else didn't get the handouts, you're welcome to come and pick them up.
So what's the equivalent of iStandard processing impl in this?
What's the equivalent of what?
iStandard processing impl.
So this is here. We don't have it. We don't have it here. But if I added persistence, if I went and made some of the choices on the wizard, I would start adding more classes that are inherited from. This is a mix-in. This really is a mix-in. A lot of base classes, and I'm adding in more base classes to add in that additional functionality. That's the way ATL works. Okay. So, but it has kind of an unusual structure. So let's look at structure.h. So I have, I think, one header file where I define everything just to make life easy for myself. So I have an object factory struct iCreatable. So this is just this. You have the diagram. So I have an iCreatable, and notice I have a static function create, and I have addref and release and a virtual destructor, and the addref and release are virtual methods. Okay? So I'm guaranteeing that iCreatable can create an object and can control its lifetime with addref and release. And it's just the way COM does it. ATL does it. I have an iStandard process impl, and this is just some hey, I'm doing some work kind of thing. But there are probably hundreds of classes that ATL defines that you can add in to get like persistence functionality and stuff like that. And so it has an interface and implementation. Now here's the components interface. So now I'm gonna, so here's my component. This is what we think of. We're here in the test function, okay? And that's us. What I just did is test here. That's the component.
So this is the test.cpp?
Test.cpp and yep, and test.h is the h part of it here. So this is test.h. Okay. So the components interface, I implement the addref release and query interface. Okay. Now these aren't real COM. These are just my simulations of that COM interface. Okay. And I'm going to do it. I'm going to keep it pretty simple. And so that's the IUnknown struct right here. And then iComponent is, I'm deriving from that. That's where I define whatever processing I'm going to do. We define put string and get string. I'm defining some comp processing to represent that processing, whatever it is. Okay? And now I have class A component sitting right here. That's what when we use ATL, we're thinking of, that's our component. That's what's building that really isn't the component that's created. Okay? ATL does a little trick. So, but here, our A component, so this has got to implement comp processing. This is our component, so it has to implement the interface that we defined, and we just defined a single method called comp processing. Okay, so, and it doesn't do anything useful, it's just a demo. Now here's the real component, which derives from a component. This is the guy that actually gets created. Real component is what gets created. And real component adds methods for add ref and release and query interface. And this is exactly the way ATL does it. Okay? So it hides it from you, and it derives from your class to add in that functionality. And then I implement iStandard processing, and I implement iCreatable. So iCreatable just says iComponent star pcomp equals new, the real component, not what I'm thinking of as my component, but the real component. It creates an instance of that, calls addref on it, and returns a pointer to that component. That's just exactly what com does, and this is structured just like ATL. So in the main, I just create an instance. So that's pretending to be co-create instance. So co-create instance is going to go off and get the class factory and create an instance of the component and return a pointer to the. So I'm just doing it in one step, just a quick, So I get a iComponent, iCreatable. And now I get a standard interface and do some standard processing. So now iStandard process impl pstandard pcomp query interface. So I really did that just to show you, this is what com is doing. You query interface to that standard processing, and I can do it. And now I'm going to query interface for I already got returned a pointer pcomp at line 16 already returned, so I didn't have to query for it. I already got it from the factory, okay? And now I just do my processing. So that's really the way the way ATL works. Yeah.
Where in for like the create function for the iComponent, where does it actually connect with like the aComponent class?
So what happens here is, let's go to the class diagram. What happens is that the real component derives from a component, so a component and all its methods are right there and callable. So if I have this object, I interact with it just like I do with a component.
Okay.
It just happened, it's just wrapped the add, ref, and release and query interface so I can use that too. It's what provided me the code to implement that upper interface. And it's kind of a strange structure. I wouldn't write code that way, but that's the way ATL is written. So I did this to make sure I understood what ATL was doing when I first started using ATL. Okay. Yeah.
I don't get it. Why doesn't the real component inherit from like iComponent and iCreatable?
It does through a component.
I mean, why doesn't it directly inherit?
It could. I'm doing what ATL does. Like I say, I wouldn't necessarily have structured the system that way, but this is the way ATL works. Okay? So there's nothing wrong with that. Perfectly plausible, feasible, doable. A component has the functionality that I'm trying to provide, and the real component just adds on the processing for the DLL, okay, the server processing.
Like, a component derives from all this stuff. But
Yeah,
doesn't-
see, they're trying to use a mix-in strategy. They're trying to use a mix-in strategy. That's what they're trying to do. So that I can add and remove at any time. I can, you know, if I want it to work this way, I add stuff in. Or if I don't want that, I take stuff out. That's what the mix-in strategy does for you. And you know, this is how you get a mix-in strategy to work.
So why not mix out the stuff in the real component instead of a component?
Because now my user would have to implement that add ref and release. This, the real component is implemented by the ATL library and derives from our component.
No, I'm saying why, like, not.
If I don't provide the real component, you, the user of the library, has to provide that code. You have to write add ref, you have to write release, you have to write query interface. Doing it this way, you don't have to write that. The library writes it. It just, because this is a template class, he can derive, okay? Your class is a template argument, so he can derive from you. Okay?
I guess more confused. Doesn't ATL or Visual Studio provide the real component?
Yeah. ATL library provides the real component.
So like the client doesn't have to write that code.
The client doesn't because of this structure. The client doesn't. So what the client gets when he gets a pointer, the pointer points to the real component, but as far as the client is concerned, it's just a pointer to a component that, by the way, add ref and release just happens to work. Okay? As far as he's concerned, the pointer interface is the stuff he knows about. Okay? But he didn't have to implement it. It's just ATL's way of implementing that functionality so your code didn't have to implement it. Somebody's got to implement it. Okay? And it wants to be part of that object. Right? So you got that's exactly what you get. What you got here is a structure in which I can plug in or out any functionality I want here that my custom interface here is I implemented in the component, and all that other stuff that isn't part of the custom interface, the library implements. That's what inheriting this way, that's what it does for you. Okay.
What's the better way to do this? You mentioned that it's not the best way to do this.
Oh, given all their objectives, I might come up with, I might do it this way too. This certainly is workable. It's a little, you know, so a rash is, you know, what's going on here? Okay. And when I first looked at the ATL code, I said, what's going on here? Okay, that's all. But from a functionality point of view, it's quick, fast, has this nice mix-in, you know, behavior. So.
Professor?
Yeah.
Where's the comp processing of a component coming into picture in the real component here?
Say this again, what's your question?
Where's the function comp processing of a component?
So what's happening here is the COM processing for add ref, release, and query interface is done here.
Okay.
Okay. The processing for my code, my custom code, is in a component.
Okay.
Okay. All right. So with that, let's see how I want to do this. Let's pull up ATL improc EX1. Now I dragged you kicking and screaming through improc underscore EX1 raw C++ component, you know, and some of you guys did a pretty good job of asking questions and paying attention, and some of you were saying, oh my God, when is this going to end? Okay. But this is doing exactly the same thing. Now, you say, why didn't you call it ATL improc underscore EX1? And I didn't because the wizard gets confused if you put an underscore in it. It's a bug in the wizard. What happens is most of the file names have that hyphen in it, but the IDL doesn't, and so the IDL generates files without the underscores. Somebody just dropped the ball on that one. So my advice to you can do it. You can use an underscore in the name if you want, but now you're going to have to go do some fix-ups. And I'm afraid that you're going to have to do some fix-ups not only in the stuff that stays, but also in the generated code. So every time you compile it, you got to go and fix it up. So you don't want to do that. So just don't use any underscores. It's just a bug, stupid bug in the, and it bit me bad. Yesterday morning I was working on this, and I expected it to be, 40 minutes of work, and it was more like 3 hours of work, okay, because of several stupid things like that. But anyway, so now we have the IDL, and I didn't write this. I put the comments on at the top, but the wizard wrote it. The ATL wizard wrote it. Just like the ATL wizard wrote our IDL here. So the ATL wizard wrote that IDL, and the ATL wizard wrote this IDL. But I decorated a little bit. Now, the IDL serves as a header file for us. And so, and everything else is generated. You don't want to write comments in code that's generated, because if you rebuild it, your comments went away and you get to put them in again. So I like putting in this manual page, maintenance page information in the IDL file. That's what I do. I'm using, the wizard gives you object, and I turned that into OLE automation so I could use the standard marshaller. Don't have to get involved with, it would have worked fine leaving it as object, but this lets me use the standard marshaller. Now I have a put string, get string, just like I did with the wizard, but this is what improc underscore EX1 did, so I'm just doing exactly the same thing. And now, if you look at the code, we'll come back to the notes in a minute. If you look at the code, there is strings.h, so it generates, instead of comp underscore I.h with all kinds of crazy plumbing stuff in it along with your interface, this just generates the stuff that's appropriate for you. So you see at line 21, class ATL no vtable C-string, blah, 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 blah. Now that no ATL, no vtable, because of the particular structure that ATL uses, they're not using a vtable per class, okay, and that let them save a few bytes of storage. God bless them. Wrong choice to make, I think, but that's what that decoration ATL no vtable means. We're going to do something that avoids building a vtable for each class. And C strings is the name of the class. ccom object root exe. Notice that it is templatized on a single thread model. This is the guy that does the lifetime management, and ccom co-class is the guy that does the class factory, creating the instance. Now, instead of the custom interface, because we did a dual interface, all we see is the iDispatch decoration. But that iDispatch decoration really has all the information that the custom guy has, and so instead of having them both appear, they just use the iDispatch mix in, but you have all that custom stuff available to you. Now I have a constructor that if there was some reason I needed to do something at line 27, I could add some stuff. So, for example, if I decided to add some variables to the class, which I often do, you often need to do that, you can initialize them there. Okay, and this map is really a macro that expands into the if you expanded it out, you would see the interfaces fully, you know, the iStrings interface fully laid out, and the iDispatch interface fully laid out. Okay, that's what that, just macro. Microsoft loves macros from the old days, and you know they've been using these kind of macro maps for a long, long time. It started with Windows when everybody was developing GUI applications from native Windows. Their first improvement was a framework that laid out there's a message handler in the classic Windows that for each message there's a little case, it's a big switch case, that for each message that you want to handle, you provide code. And those switch cases would go on for 2 or 3 or 4 pages in the big application. So what they did was they generated that from macros. They had a map for each message, you know, just so they've been doing that for years. Now I have the declaration at line 56 and 57 for the 2 methods, public. And now, you're perfectly welcome to add in private here below it and add some data members if you want to, if you need to for your class. It works just fine. I do it all the time. Now we have strings.cpp, and it's just those 2 methods to fill in. So this is moving us closer to the kind of development we do with regular C++.
Sorry, this is at the end of strings.h.
Okay, the end of strings.h.
Is this function?
What line are you at?
56 and 57.
56 and 57. These are the declarations for the methods that we're going to implement that have to be in the header file. So it's just declaring them. Are you puzzled by the standard method?
I'm puzzled by the syntax. Is it like function pointer syntax?
Are you concerned? Are you confused about the beast or star?
No.
Okay, so it's the standard method put string and standard method get string.
Are they macros?
Those are macros that expand to qualifiers, you know, that tell the compiler how to set up the stack frame and tear it down. Okay. Don't ask me what object entry auto does because I don't have a clue. Okay. At the very end of the header file. I don't have a clue what that does. It does, if we looked at the doc, we could consult Dr. Google, paste that in, and it would tell us what it does. So, okay. And, now I write a client. I'm done. That's all I had to do. So I used the wizard, bang, 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 There was a lot of stuff to write using the raw C++, a lot of stuff to write and get correct, but all of that was put in place. It's all just boilerplate, and so ATL was developed to give us automatically that boilerplate and let us just add in our part for the functionality. Now let's look at the client. I'm going to use com pointers here. I think I do. Let me see if I do. Yes, I do. So I'm going to use some of this ATL-based tools in a minute. So in my main, so now the includes at line 29, 30, and 31 were provided by the wizard. So this ATL improc ex1 underscore I.h is the file that has all those weird, it's just like from our raw C++, same kind of stuff, all that nitty-gritty details for setting up the interface. And ATLBase is where a lot of that infrastructure comes from. Where did the query interface, add, ref, and release come from? ATLBase. And lots of other stuff. But I added IOStream because I'm going to use streams, but I'm sorry, I lied to you. The wizard didn't write any of this. I wrote it all. I was thinking about that. So, but in order to use COM, you need to include ATLBase because, for example, at line 39, I'm going to call co-initialize EX. And that function, the compiler will say, I don't know what that is, until you pound include ATLBase. Okay? So I'm getting all the basics for ATL. Now I say co-initialize EX, co-init apartment threaded. Co-initialize EX is an extended version of co-initialize, which will allow me to build a multi-threaded apartment if I want to. So I tend always to use co-initialize EX. In case I wanted to change my mind and turn this into a multi-threaded apartment, then it's really easy to do. There's a different, this coinit underscore apartment threaded is an enumeration, and there's a coinit underscore multi-threaded that we could use. So, and if it fails, it just says, hey, I couldn't initialize COM. Now, I have a try block, and I'm going to come back to this comment at line 47 in a minute. So at line 55, CCOM QI pointer I strings P strings. This is a smart pointer that ATL gave to me. And what this does is I don't have to handle H results now. I don't query H results. What happens is if there's a failure, this pointer value is 0, sort of like a dynamic cast. Okay. And so I say if P string's not equal to 0, so I didn't have to do that. If succeeded, blah, 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 blah. And now, as long as it succeeds, I just call P strings, put string, high from client. Now, I'm using a beaster as that input parameter. That was typed as a beaster. But what's happening is so my hesitation at line 60 is I know that you can supply a Unicode string to any function that's accepting a beaster, but I've forgotten why that works. Beaster must have a promotion constructor. I'd forgotten that. Beaster must, Beaster doesn't have a promotion constructor. That's what I'm hesitating. If I had typed it as taking a CCOM beaster, it would make sense to me. I've forgotten why. I'll have to look at that and get back to you. But now, what I'm going to do, so getString is going to return a beaster, and I am declaring at line 69, ccom_beaster return string. And I'll show you why in a minute. So using the comment, using ccom_beaster as an out parameter, we don't need the call to empty here because we haven't used return string. What happens is if that beaster had some stuff already loaded in it, and now I write into it, that contents will be a memory leak. It'll be replaced by, but that storage won't go away. We didn't allocate it. We'll replace that with our own pointer, okay? And so what happens is if you had contents in a beaster and you're going to want to use it as a return type, you need to empty it. That just deletes that using the com_cotask mem free, or whatever it is, okay, the com allocator, it frees it. And that's what ccom_beaster does. If we were using standard beasters, I would have to do the com_cotask stuff myself. But the com_beaster wrapper takes care of that. So now I call pstrings getString with the address of return string. Remember that this is a C-style interface. So I declared at line 69 the return string, and now I'm giving my server that reference to that location 69, or my proxy if we were in different apartments, and now that'll just write into that. When I'm returning that string, that'll just write into that. And now at line 78 I call detach. And what detach does is it deallocates the storage associated with that string. So I've used that string. So I printed out the length of the string, and I printed out the return string and detached it because I'm not going to use it again. Using a beaster as an out parameter, we're using an unnecessary allocation before the call to simulate what ccom_beaster is doing. You always want to supply an unallocated string that the proxy allocates and fills, and you can use and deallocate. So, here's my beaster return string, sysalloc string, and length of beaster before the call, system string length. So I've forgotten what I did here. Bear with me for a minute. Oh, yeah. What I'm doing in this client is I wrote this 2 years ago and I've forgotten. I think all I'm doing is demonstrating the allocation and deallocation and the detaching, the difference. So I print out the length and then I detach it and print out the length is what I'm doing. I'm getting, at line 92, I'm getting the string, address of our string. So yeah, I've done it. So I've done it two ways. I've done it with a ccom_beaster, okay, And now at line 87, I'm doing, that's what I'm doing. So at line 74, I'm calling getString and putting it into a beaster. The beaster I defined at line 69. And now I'm just showing you, here's how you would do it without CCOM beaster, just using the beaster itself. So now you have to allocate the memory and free it, and I didn't have to do that with the CCOM beaster. The CCOM beaster and detach took care of everything for me. That's all. That's what I was illustrating. Says free string, else. So if it didn't succeed, then I throw a standard exception for my client. Co-create instance failed. That's just from the co-create instance. Now. There's a quirk with these. The smart pointer at line 55, CCOM QI pointer, that will call release when it goes out of scope. Now, if I didn't embed all this stuff in the try-catch block, what would happen is I would call co-initialize at line 113, and if this CCOM QI pointer was at the same level of scope as the co-initialize call, then I'd get a beautiful exception, because I would call release after I've torn down the apartment. I'm trying to do a COM operation without having the COM infrastructure anymore. So anytime you use these smart pointers, you have to put them inside a scope that's inside the apartment creation and the apartment teardown, the co-initialize and co-uninitialize. Okay, that's all. Just because that CCOM QI pointer was designed so that you don't have to remember to call release. It calls release when it goes out of scope. But now, if you don't embed it in I'm embedding it in this try block, but if I didn't have a try block, if I didn't decide to do that, then I would have had to have used something like an anonymous scope and put it inside that, and it would have worked fine. But anyway, that's that client, and you say, okay, so that's a COM client. Here's my C# client. And it looks a little easier. Surprise, surprise. Okay? It was designed to be easier. So the only thing about this C# client is that I got to figure out how to get my handle on the COM component. And you do that. Let me see if, with luck, I put this code on my laptop. I forgot to synchronize my laptop, so I know it's not on there. I can't run it for you today. I'll run it for you on Tuesday. But, and I'll show you exactly how I can show you here. I can show you here on this little thing we built. Let's pull up the object browser. Here's the object browser. And let's look at the ATL library. So here's the ATL library right here, okay? And so what you see here at line 20, improc_exlib, that is in this program, it is the ATL Project 1 Lib. And here's my test, you know, and it has those, it has the methods I can call. So there's ctest and itest. So what my C# client needs is that reference, and you find the name of that reference from the browser. You use the object browser, and you look at the component, and it'll tell you the name of the library, and you use that in C#. There's one other constraint about C#. C# by default comes up with a build for any CPU. That won't work for comp. Why? I don't have a clue. You have to say x86. You got to make it say x86 or it won't work. So, and that causes lots of consternation, you know, until somebody says, hey, you got to, okay. So I put some of that in notes. If you look at the page just after the IDL, I have a notes page. So here's things you got to remember. One, don't use underscores in project names. That seems to confuse the new ATL wizard. It's brand new as of this version of, not 2017, but as of this latest version of 2017. So don't use underscore. The IDL file doesn't have the underscore and generates code with names that aren't recognized by the other files during the build. And you can fix it up, but it's a chore. Two, your interface or server IDs aren't recognized. If your interface or server IDs aren't recognized, look in the project name, whatever your project name is, underscore i.h file to find the names of that ATL expects. So that just says, oh my gosh. That just says that I go into underscore i.h and so here's one. Here's the symbolic form of my interface, IID underscore test. So that's what you use in the when you're doing query interface, and where is the component? The component's somewhere. Class ID, where are you? Yeah. So here's the class ID. So this happens to be class ID underscore test. And this is the type library. We aren't using the type library. We have some time in between presentations. Later on, I'll talk a little bit about it. But, you know, the normal thing is that you're using the project names like ATL Project 1 Live and so on. But, you know, they aren't always exactly the same, and so if you don't get a match, if it fails, then you go just look at this file to get the right names. So that's what 2 says. 3 says your C++ clients need to add the project name underscore i.c file to the project. Don't add the project name underscore p.c. Okay, that's the proxy code that the component uses and the runtime uses, but your client. If your client includes it, it won't build. C# clients must be compiled with the x86 build target. C# console wizard sets that to any CPU which doesn't work with COM interrupt. Okay, so as far as I know, those are the only caveats. And you in Project 1 have to build a C# client as well as a C++ client. So this is kind of a model. All right.
Professor?
Yeah.
You showed us how to add a method, but how did you add the interface and class in this serial project?
So what I did was so I went to the class view. So what happens is as soon as I add that simple object, I'm going to have an interface, but the interface doesn't have any methods. So I said, it gave me a name, but I changed that name to test. And so my interface was iTest. Okay? And so now what you do is in class view, so you need to go to class view, and now you'll see the iTest interface, and here, to add a method to it, you need to right-click on it and say add. Okay? That's all you got to do. Now, the last thing that's here, I'm not going to talk about today. I thought we might get time, and we didn't come close to getting time. The last one says, didn't I bring that in? Isn't there a project 1?
There's project 2 here.
Project, yeah, it says project 2. Somebody walked off with my whole stack. That's okay. I have one up here. That's fine. Doesn't matter. They're for you, so doesn't matter. Yeah, I have one up here. So I don't have one up here. So let me borrow yours just for a minute.
I don't have it.
You don't have project 1? Project 2?
I have project 2.
Project 2, that's what I want. Yep. Okay, that's okay. So, so what this does is, this one is a project quite like the one we just looked at. Just a simple little application. But it uses something called connection points. It's like a delegate in C#. And we'll talk about connection points, but we may not get to talk about them until the space in between the technology presentations and the programming presentations, but I will talk about them. This is an implementation of connection points. And the C#, there is both a C++ client that uses them and a C# client that uses them. And the C# client is, you see a delegate. The connection point turns into a delegate. What's going on here, was this yours?
Yeah.
What's going on here is for C# to talk to a COM component, the wizard builds something called a runtime callable wrapper. And what that is something that looks like a C# class on the C# side, and something that looks like a COM client on the C++ side. And I'll bet my bottom dollar it's written in C++ CLI, managed C++. Right? Yeah. So, is that an extra one?
Yeah.
Ah, thank you. Okay. So, we'll go over the connection points. For now, it'll be a little confusing for you to look at this ATL Project 2. I thought we'd get a chance to talk about it, but we're not even close. So, what I do want to do in the time that remains, and there ain't much time, is go back to the presentation. So, I did an experiment on you. Normally, I start with the ATL presentation first, the general, and go toward the specific. And I said, gee, maybe it'll be a little easier if we look at a simple specific and then back up to the more general case. Okay, the Socratic method, or maybe something. Was it Socrates that did that? I don't know, one of them. But anyway, let's take a quick look at the presentation. We won't have time to finish it, but it'll give you, get you started looking at it this weekend. So what's here? This is a little comment about the wizard, and you just saw me use it. So, if you get confused, it isn't a screenshot by screenshot by screenshot, but it's enough to get you going. This is the one that we looked at in a little bit of detail, the ATL improc EX1. It's the, and then this one is does some stuff that I think you may need on project 1. Mainly, it's using safe arrays to pass beasters, arrays of beasters back and forth. You can see, definitely can have designs that don't do that. But you know what? Instead of looking at that presentation, I'm going to do this presentation on Tuesday. Let me just make some comments about Project 1. I did something specifically so the model of Project 1 is that I have some sort of file manager component. That's a COM component. I have a text search component, and I have a client. And the client has to talk to this guy to tell him the path that he wants the file manager to look at. And he's got to talk to this guy to get the results. And this guy talks to this guy. The arrow may point the other way depending on whether you push or pull. Okay? And I did this. I don't want you to put these together in one component. Because with this arrangement, you have to pass a COM pointer through an interface. You have to. So, for example, suppose the client created both the file manager, he called co-created instance for the file manager and for the text search. Now, for the file manager to send his stuff to the text search or for the text search to go get stuff, if the file manager is going to send it, he needs a pointer to this guy that only this guy knows. So how does he get it? There is an interface that passes that pointer. So the client, after he's created these guys, he now has this text search component, and he just uses that interface and sends him the pointer. Okay? You're not allowed to pass around interface pointers. You know, if everybody was in the same apartment, which we probably are, it would work. But the model is we want these components designed so that one can talk to another one, and there are different security models or different threading models, so absolutely should be able to work that way. And that means, since they may be in different apartments, it's critical that you pass that pointer through an interface, because that's what tells COM, make a proxy stub channel. You don't tell it to. The fact that you passed it through an interface, there's one other way to do it, but the fact that you passed it through an interface tells it. Now let's suppose we did it another way. Let's suppose that instead of the client creating this guy, the file manager component then acting as a client created this guy. He could do that. But now the client needs to get this. And so that means that now instead of the client sending this pointer here, this guy's got to send it back. So the client has to have a function that says get text search component. Okay? So you're forced, in project one, I intentionally tried to force you. And there's an example. There's an example in the class account called component calls component that does that. Now I will warn you, COM components tend to break every time Visual Studio changes.
So, Professor?
None of these did. This one I built from scratch. That one didn't. But I have been updating some of the. They all tend to fail. They have written into them. For example, if you look at the sgafx.h, it has a Windows version, and every time when we went from Windows 7 to Windows 10, breaks. And there's a whole bunch of things like that. There's a parameter in the properties of the MIDL compiler that says it's got to be, and so lots of things to make it break. And so it's kind of laborious. You got, you can do it, but it's been on my agenda to do a little. Here's the ugly walkthrough you got to do to get this right. And I was telling you, I spent, what I thought was going to be a 40-minute job, I spent 3 hours, okay, getting it to work just to track down all that little stuff. So, yeah.
So are you advising that try to minimize components creating other components?
No. Perfectly okay to have one component. What I'm saying is that this design was laid out specifically to force you to pass an interface so that you had the experience, so you can do that. Normally, we don't particularly want one component to create another one because that gives there's a dependency now between those two components. But so if the client creates both of them, then this guy just needs a pointer, and he doesn't care to who. He just needs a pointer to say, here's how I send those results. Or the other guy needs a pointer that says, here's how I get the results, and they just have to have the right interface. So they're really independent. You know, they can be used independently. Were I building these components and the stuff I wanted to reuse, I would have the client create them and you know, pass the pointer to the other guy instead of having one be a client of the other. But there's nothing wrong, you know, nothing wrong with doing that. Perfectly.
So finally, you're saying that the client has to create the pointer for text search component and pass the pointer to file manager.
So the file manager
interface.
can find it,
Okay.
can find the text component. Okay? Make sense?
Professor,
Yeah.
is ATL C++ exclusive?
Is
Is ATL C++ exclusive as for this project?
Yeah, well, I mean, you saw me, I built a C# client, but it's only going to, the component itself is going to be in C++. COM is a C++ technology. Okay. COM is a Microsoft C++ technology. Okay. But even if you know, just, I think you need to know COM just to be capable on a Windows platform. Because things will happen to you. Windows platform is COM everywhere, and so you'll run into problems, and unless you understand COM, at least a little bit about COM, they're going to totally mystify you. You won't know what's going on.
Well, I was
Okay.
wondering
But-
if I could use CLR in the file management
No.
component.
No. You can build COM components from C#. You have, you know, what it's doing is it's building C++ components indirectly, and because it's indirect, from a language that doesn't really, you know, understand all those details, it's very limited. So there's a way to do it, but it's limited. The Windows RT, the new, you know, Windows RT, was invented to wrap COM objects with managed code in a more flexible way. So, you know, and that's the technology that they want you to use to build Windows apps and phone apps, or, you know, Windows phone apps and stuff like that. So, yeah. Okay, so on Tuesday, I will go through this ATL presentation, but it'll be fairly quick, and I'll talk about connectable objects, and we'll look briefly at that project. So bring project 2 with you when you come on Tuesday. We have a pretty strong agenda. You know, I normally, this class is bigger this year than past classes, and so I had a little more time, and I just ran out of time. So, but we will cover enough so that you can do project 2. And, you know, if I don't tell you enough before the technology presentations start, I'll simply move back the due date for project 1 so that you hear from me whatever you need to, you know, and get a chance to ask questions before you do the project 1. So, all righty, see you all on Tuesday. By the way, I do help sessions Friday morning, and if you want, you're welcome. You know, you can ask 775 questions in the help session. If you know, feel free to. I'll be interested at the end of the day Tuesday. So Connell and Umkar. So after we have done the ATL presentation, I'll be curious on your reaction. Did it work to start and go bottoms up toward the presentation, starting from the specific, going toward the general, or would it have worked better if we talked about the ATL layout first and
I think
gone down?
the diagram helped us out.
It went well, like the
Yeah, well, anyway, we'll reserve judgment on that question, but I would like a little feedback about whether that worked, you know, because I've never done it that way before. I've always started from the presentation and worked down toward the specific, but.
I think my presentation date got switched, or it looked like my.
I did switch you,
Okay.
and I meant to mention that to you and say if that won't work for you.